Black holes are one of the most fascinating objects in the universe, and have been the subject of intense scientific research for decades. They are objects that are so dense that nothing, not even light, can escape their gravitational pull. In this video, we will explore what black holes are, how they form, and the latest research on these enigmatic objects. Black holes are objects in space that have such strong gravitational forces that nothing can escape from them, not even light. They are formed from the remnants of dead stars that have collapsed under their own weight, creating a point of infinite density known as a singularity. One of the most interesting and mysterious properties of black holes is their event horizon. The event horizon is the point of no return for anything that gets too close to a black hole. Once an object crosses the event horizon, it is forever trapped by the black hole's gravity and can never escape. The event horizon is also the boundary where the black hole's gravitational pull becomes so strong that it distorts space and time. There are three main types of black holes: stellar, intermediate, and supermassive. Stellar black holes are the most common type, formed from the collapse of a single massive star. When a star exhausts all its fuel and can no longer support itself against gravity, it collapses inward, causing a supernova explosion. The remaining core of the star can then form a black hole. Stellar black holes have masses ranging from a few times that of the Sun to around 20 times that of the Sun. They are typically only a few kilometers in diameter but are incredibly dense. Intermediate black holes are much rarer and have masses ranging from 100 to 100,000 times that of the Sun. They are believed to form from the collisions of smaller black holes or the collapse of large clusters of stars. Supermassive black holes are the most massive type, with masses ranging from millions to billions of times that of the Sun. They are typically found at the center of galaxies, including our own Milky Way. Scientists are still unsure how supermassive black holes form, but they may be the result of the merging of smaller black holes or the collapse of massive clouds of gas during the early universe. Each type of black hole has unique properties, such as size, mass, and behavior, that scientists are still trying to understand. Studying black holes can provide valuable insights into the fundamental laws of physics and the behavior of matter under extreme conditions. Research on black holes has been ongoing for decades, and scientists continue to make new discoveries and advancements in our understanding of these mysterious objects. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, made the groundbreaking discovery of gravitational waves, ripples in the fabric of spacetime caused by the collision of two black holes. This discovery opened up a new way of studying black holes and has led to further research into the properties of black holes and their interactions with each other. In 2019, the Event Horizon Telescope, EHT, collaboration released the first ever image of a black hole, specifically the supermassive black hole at the center of the galaxy M87. This was a major breakthrough in black hole research, as it provided direct evidence of the existence of black holes and confirmed many theoretical predictions about their properties. One of the biggest puzzles in black hole research is the information paradox, which concerns the fate of information that falls into a black hole. According to quantum mechanics, information cannot be destroyed. But classical general relativity suggests that information that falls into a black hole is lost forever. Research is ongoing to try to resolve this paradox and better understand the nature of black holes. As mentioned earlier, the detection of gravitational waves from black hole mergers has opened up a new area of research into the behavior of black holes. Scientists are studying the properties of black holes before and after a merger, as well as the dynamics of the merger itself. Overall, research on black holes is a vibrant and active field that continues to yield new insights and discoveries. As technology advances, scientists will be able to study black holes in even greater detail, providing us with a better understanding of these fascinating and mysterious objects. There are several theories about black holes that scientists have developed over the years, each attempting to explain some of the mysteries surrounding these cosmic phenomena. Albert Einstein's theory of general relativity provides the foundation for our current understanding of black holes. According to this theory, black holes are created when matter is compressed to such a degree that it collapses under its own gravity, creating a singularity in space-time. General relativity also predicts that black holes have an event horizon, the point of no return beyond which nothing can escape the black hole's gravity. In the 1970s, physicist Stephen Hawking proposed that black holes might emit radiation due to quantum effects, leading to the eventual evaporation of the black hole over time. This theory, known as Hawking radiation, is still being studied and has implications for the nature of black holes and the laws of physics. Some scientists have proposed alternative theories to general relativity that suggest that the laws of gravity change at very large scales. These modified theories of gravity could potentially explain some of the observed properties of black holes, such as the relationship between their mass and size. One of the biggest mysteries surrounding black holes is the information paradox, which asks what happens to the information contained in matter that falls into a black hole. According to the laws of physics, information cannot be destroyed, but it appears that black holes do just that. Many theories have been proposed to solve this paradox, including the idea that information is somehow preserved and later released through Hawking radiation. Overall, theories about black holes continue to evolve as scientists gather more data and explore new avenues of research. While there is still much we don't know about these mysterious objects, the work being done to understand them has led to significant advances in our understanding of the universe as a whole. One of the most fascinating theoretical possibilities related to black holes is the idea that they could potentially be used for time travel. This concept is based on the idea of using a black hole's immense gravitational pull to bend space and time. According to Einstein's theory of general relativity, time and space are fundamentally connected. And the curvature of spacetime is determined by the presence of mass and energy. As a result, black holes, with their incredibly high mass and gravity, can significantly warp the fabric of spacetime. One proposed method for using black holes as a time machine involves approaching the event horizon of a rotating black hole at a high velocity. Then turning around and returning to your starting point. Due to the extreme gravitational forces at play, time would pass more slowly for the traveler than for someone outside the black hole's influence. As a result, the traveler could potentially experience only a few minutes of travel time, while decades or even centuries pass outside the black hole. However, the concept of time travel through black holes remains purely theoretical and is not yet supported by any empirical evidence. In fact, the idea raises several paradoxes and inconsistencies in our understanding of time and space. Nevertheless, the possibility of using black holes to explore the mysteries of time remains a fascinating topic for both scientists and science fiction writers alike. There have been several popular films that explore the concept of black holes, ranging from science fiction to more factual representations. Some of the most well-known movies about black holes include Interstellar, Event Horizon, The Black Hole, Disney's Tomorrowland, and The Discovery. Black holes are one of the most intriguing and enigmatic objects in the universe. They have captured the imagination of scientists and the public alike, and continue to be the subject of intense research and study. As our understanding of these objects grows, we may unlock new insights into the nature of the universe itself. If you enjoyed this video, please like and subscribe to our channel for more updates on the latest scientific and technological advancements. We also encourage you to leave a comment with any ideas for future video topics. Thank you for watching.